In this chapter, we will discuss about the steam turbines in cogeneration and such-utility systems, particularly on the types of the turbines and the cycles, thermodynamic cycles in the turbines. In general, there are two types of steam turbines, which is the back pressure and condensing turbine. Steam turbines can be divided into these two basic classes. So in the back pressure turbines, the exhaust stream pressure is higher than the atmospheric pressure. So the low pressure steam here is above 1 atm. On the other hand, for the condensing steam, the exhaust stream here has a pressure of less than 1 atm. The exhaust pressure of a steam turbine is fixed by the operational pressure of the any downstream equipment after the turbine. In this figure, it shows that uh, back pressure turbines operated between high pressure steam, and low pressure steam, and the pressure of the low pressure steam is controlled somewhere else. Okay. On the other hand, on the right side here, the condensing stream can have three type of condenser. It can be direct contact, it can be surface condenser, or it can also be air cooler. Of the three types of the surface condenser using cooling water are by far the most common. So that's why it is shown here that the condensing stream using the cooling water. When a volume filled with steam is condensed, the resulting condensate occupies a smaller volume, and that is why the vacuum is created. Any non-condensable gases remaining after the condensation are removed by steam ejector or liquid ring pump. It's not shown here. The pressure of the exhaust of the condensing turbine is maintained at reasonable temperature above cooling water temperature, typically 40 degrees Celsius at 0.07 bar absolute to 50 degrees Celsius at a pressure of 0.12 bar absolute, depending on the temperature of the cooling water. The higher the pressure difference across the steam turbines, the more the energy that can be converted from the turbine inlet steam into the power. For given temperature difference between the condensing steam and the cooling medium, the lower the temperature of the cooling, the more power can be generated for a given flow rate of the steam with a fixed inlet condition. So both back pressure and condensing turbines can be categorized further by the steam that flows through the machine. Okay, in this slide you see an extraction machine. The extraction bleed off part of the main steam flow at one or more points. For example, here two points. Um, a single extraction with both extraction and the exhaust being fed to the steam mains. The exhaust here could have been taken to the vacuum condition and condensed. The extraction machine might have partition with valve inside the machine to control the extracted steam pressure. Okay, for the induction turbine, uh, it works like extraction machine except that it is in reverse. Steam at higher pressure than the exhaust is injected. So you see an injection of steam here. Steam the steam at higher pressure than the exhaust is injected into the turbine to increase the flow partway through the machine and to increase the power production. In the situation shown in this image, an excess of medium pressure here, uh, an excess of medium pressure steam generation over and above that for the process heating is used to produce power and exhaust into the low pressure steam here, where there is a demand for the low pressure system for the process heating. The steam condition and forward generation typically depending on the steam pressure. So when the steam pressure at range of 10 to 27 bars, the typical power production is 0.75 megawatt with efficiency of 35 to 45 percentage. As you increase the steam pressure to, let's say here, 60 to 140 bars, the power that can be extracted typically increase to 40 to 90 megawatt with the efficiency of up to 80 to 87 percentage.